So let's talk about this next article.
Yeah,
Quantum batteries that charge wirelessly might never lose efficiency. So we talked recently about that nuclear battery
yeah.
that lasts 50 years, charges itself. What's going on with these quantum batteries?
Yeah, so this one really challenged me to fully understand. So we'll dive into it, but there's a lot of quantum mechanics and quantum physics that are coming into play here that I really need to do a deeper dive. But like, let's talk about it on a high level. We can talk about the differences and different things like that. So the article, so again, this is a theoretical concept. Okay, so it's a theoretical concept called quantum batteries, which potentially could revolutionize energy storage if proven viable. So what quantum batteries would do is they would exploit quantum effects to rapidly charge wirelessly through an electromagnetic field generated by a hollow metal tube connected to the battery. What the wireless charging does is it avoids the energy loss issues seen in conventional batteries from chemical degradation due to repeated charging and discharging cycles. So, one of the proposals involves trapping atoms or photons at ultra cold temperatures within a superconducting material and then drawing the power from ambient magnetic or electric field oscillations. So, unlike normal batteries, quantum batteries may never lose their charge over time if disturbances don't disrupt the delicate quantum states storing the energy. So just to get into like, okay, so there have been some experiments that have wirelessly charged simple quantum emitters, but there's a lot of major challenges that remain in scaling up the efficiency and connectivity over greater distance. But if it's realized, quantum batteries could fundamentally change industries like EVs, devices, and more by removing limitations on hours of usable power between charges. So kind of similar to the length of the nuclear battery, but this one needs to be charged. So, kind of just to summarize, quantum batteries they do offer an intriguing prospect of batteries that may never lose efficiency if there are key technical hurdles around their design. So, the proposed mechanisms for the different types of quantum batteries um, are based on ultra cold atom molecules, quantum dots, superconducting circuits and the specific electromagnetic coupling methods that have been explored so far using microwave or laser beams through a cavity or waveguide structure. So there's a lot of lot of complex, way beyond my understanding of quantum physics, quantum mechanics going on here, but really, really cool stuff.
Yeah, I've looked at this and I've got lots of questions.
Yeah.
We've got one here. What kind of distances are available for wireless charging? Is it, right beside it or is it across the room?
I
Are they
think it's like definitely within the same room right now. But if we're talking about lasers, like we could probably do across a big room, but right now it's microwave or laser beams through a cavity or waveguide structure. So um I don't know what the distance would be for that right now. Like obviously microwaves can be transmitted over a long distance, so can lasers, but laser beams have to be line of sight. Microwaves, I think you can bounce it off the ionosphere. I can't remember my my education now. But anyways, they have to be beamed through a cavity or waveguide structure right now. So
they don't that doesn't sound healthy to humans.
absolutely not. Not microwaves for sure. Lasers, yeah. But definitely but how powerful are these lasers going to have to be and what kind of structure are they going to have to be? So this is again, we're talking something that's theoretical. Few experiments have been done. Just the experiments that have been done are on wirelessly charging quantum emitters. Not even on the quantum batteries themselves. So this we're talking super future tech right now.
Yeah, I saw some info saying quantum batteries they take these batteries leverage quantum effects for fast charging. Sorry, what does that mean?
So um the so what the quantum effects are quantum, I think, and again, I could be wrong, are quantum entanglement that they're using for this.
Okay.
Um, but again, so it involves trying the quantum states of particles together, or sorry, tying the quantum states of particles together, such that measuring one particle instantly affects the state of the other, even over long distances. So, what they've theorized was transmitting power through quantum entanglement could allow batteries or devices to be charged, and this gets into your remotely stuff, without any physical connections or wires. The way it works is by entangling electrons in the battery with electrons in a charging station. So you're manipulating the electrons at the station, then that manipulates the entangled electrons in the battery in a synchronized way to transmit the energy, which is like super sci-fi right now. So this could allow recharging from a battery from miles away, theoretically, if they get this entanglement. So that goes beyond what the experiments that they were doing. So yeah, the battery and charging station would need to maintain quantum coherence over long distances, which definitely becomes difficult.
So now takes on, now that I understand what we're talking about here. So we're talking about quantum entanglement, and theoretically, there's no limit to the distance. We just don't know.
Yeah.
So the concept is I've got a battery plugged in at home, charging all the time, and I'm driving around in my quantum battery powered car that is charging, while it's
Yeah,
using the battery. And technically, at a quantum level, they're the same battery.
exactly. So the thing to note, though, is that quantum teleportation experiments have validated these entanglement principles with over 1,000 kilometers, but applying it for charging is definitely far more demanding.
Yeah, I'm very curious as to what kind of power it would take to,
Yeah.
you know, do the quantum entanglement. Does it actually require power after that? Like, as far as to transmit across the distance, or does it just happen? And, is that, again, there's some weird quantum stuff that, quantum physics is magic. And so, is it, I curious, we're all curious is how all these things kind of work together from a, um, how can we possibly transmit energy over thousands of kilometers without actually transmitting the energy?
Exactly. That's the thing, and these are concepts that are quantum physics concepts, right? That we'd have to dive into a lot more. And you and I have know the basics of quantum entanglement, um, but it's it's not so much. It's affecting a proton, or it's affecting one particle that is affecting another particle that's entangled with it at a long distance. So so if you're charging one, you're charging another without physical connections or wires.
Yeah. So it's very interesting. I like it. There's also some stuff saying it's susceptible to environmental disturbances. Now, quantum is susceptible to any kind of disturbance,
Yes.
apparently. Like, they're so noisy. Are these batteries even more susceptible?
Who knows? It all I don't it all depends on the complexity of it, which again, they're going to have to get it beyond the theoretical state in order to do that, or actually do some more math in order to to design even sort of any kind of experience to figure that out. But again, the only experiment that was done was that a validation experiment of entanglement principles. That's it. So there's a lot more that's going to be needed. Like we're talking, I would say we're unless breakthroughs happen, we're 50 years away from anything like this.
And we talked before about the nuclear battery,
Yeah.
and it powering our devices. What are some of the challenges of developing a long-lasting implantable device powered by quantum batteries, say like in a pacemaker or anything inside you, versus the nuclear battery?
Well, the biggest thing is the utilizing quantum mechanical effects, like quantum tunneling and entanglement to generate that electricity. Um, which, so for those that don't know, um, for the quantum batteries, there would be no radioactive material would be needed. I don't know what that quantum battery would be using as far as materials. Um, but it's less about the materials and more about the quantum entanglement and how that is going to remain charged. So um, again, we'd have to look at how that entanglement's going to happen, how that entanglement's going to work, and then the maintaining of that entanglement kind of connection, if that makes sense. So there's a lot that comes into play. But the good thing about this versus the nuclear batteries is there's no radioactive material.
Yeah, that was always a concern. I didn't want to put radioactive material in my phone and next to my head or in my body. And but we'll have to see Futurize where this goes, because this is literally wireless charging through whatever. We have no idea what kind of effect that would have, having that go through your body. Does that have any effect whatsoever? Does it actually go through your body? Is it a
That's the thing.
subspace
I don't think it goes
transmission?
through your body. That's the thing. Yeah.
But what
But
does that mean? Is it subspace? Is it, powered by some sort of dark matter that the universe, we're only seeing, that the whole universe is actually more dark matter than the stuff
honestly,
that we
I
see?
think it utilizes concepts that we can't even fathom at this point, as far as how that would work as far as the quantum entanglement. I think it uses it. So back in the day when I guess electricity was invented, I think that's where we're at with this, as far as quantum batteries go, where people think it's magic, people think it's hokey pokey. um, but I think that's where we're at right now. We're at that
Like
stage.
they say, any scientific advancement enough can be, the equivalent of magic if you're scientifically advanced enough. So maybe, but
Yeah.
yeah, I'm looking at this as magic. But what companies are working on this, and what kind of research projects are they doing?
Yeah, so there's quite a few companies that are working on it. There's a university in the Netherlands are working on quantum batteries based on lithium ions embedded in diamonds. We've got the Oak Ridge National Laboratory that are developing superconducting quantum batteries using microwave photons. IBM is doing some stuff, so they're exploring trapped ion superconducting chip approaches. Um, there's a company, Quera, which actually I think they're in the news recently about Quera just announced something about error corrections. I think just like yesterday or something. So they're a spinoff of MIT, and as it relates to quantum batteries, they're exploring trapped neutral atom quantum batteries for high power needs. Harvard and MIT are prototyping quantum dot quantum batteries, integrating semiconductors with 2D materials. And let's talk about some Canadian companies. Quantum Energy is focused on room temperature gas phase quantum batteries using electromagnetically induced transparency. And PsiQuantum in Canada is developing trapped ion quantum computers and applying related photon battery concepts. So there's a lot of there's a whole list. There's even more that I didn't even get into. There's some German companies, some companies in the Netherlands. I don't think there's any Chinese companies in here, but yeah.
And we got one comment says, "I want one. Can I order it on Amazon Quantum?"
We'll have to see. Yeah, you'll have to entangle that order, so someone else will have it and you'll have it too.
Yeah, that was. I think this is cool. I
Yeah,
think this is futures ahead. The nuclear battery apparently exists now, so I'm
yeah,
curious to see. We're going to see that before we see this, but it sounds like this is an interesting long-term solution.
yeah. Just to kind of put it into perspective, the lifespan of a quantum battery theoretically could last thousands of years, versus the nuclear battery, which has a lifespan, I think, of 30 plus years. So
Yeah, they were talking 50 years in the article. Yeah,
yeah, yeah.
completely different, but definitely a step in the right direction.